Now the next rule is, in case of pi donors, the number of pi electrons involved in donation from a particular ligand are indicated. Now how the number of pi electrons involved in donation indicated and what it actually means? First of all, we'll see how the number of pi electrons involved in donation are indicated. It is indicated by some term called a hapticity, which is indicated by eta raised to the power x. And this x here determines how many pi donors are involved. When we talk about cyclopentyl dienyl anion C5H5 negative, it is abbreviated as CP. It's abbreviated as CP and it looks like this. Dienyl, so there is 2 double bonds and it's an anion, so there is a negative charge here. Now if only the negative charge is donated to the metal atom, then only one carbon is involved in the donation. Okay, 2 electrons are getting donated, but only one carbon is involved in the donation. In this case, hapticity is going to be 1. So you're going to write N1C5H5. Now in case, see, resonance can also happen, that is, this negative charge can go over here and this negative charge can go over here, such that these 3 carbon atoms are in resonance with each other. Okay, that is, the negative charge is localized over these 3 carbon atoms, and if the negative charge is localized over these 3 carbon atoms and then it is getting donated to the metal, that means 3 carbon atoms are involved in donation. So this will be written as eta raised to the power 3 C5H5. And if all of them are involved in donation, that is, once the negative charge reaches here, then it is further delocalized over here. So all of the carbon atoms are involved in donation. There are 5 carbon atoms involved in donation, so it will be N5C5H5. That is, hapticity is 5. In this case, hapticity is 1. In this case, hapticity is 3. So when hapticity is 5, the negative charge is delocalized over the entire ring, and that is what is donated to the metal. So this is the case of a pi donor. So we'll do questions now based upon IUPAC naming, which is a culmination of all the rules that we have studied till now. So question states, what will be the name of this complex? Now cation will be named before anion, so first we write potassium, then give us space. Then we have to write the name of the ligand first. What ligand is this? C2O4 negative. It's oxalate or oxalato, because oxalate, it ends in ATE, so it will change to oxalato. So, and there are 3, so it will be trioxalato. Now this complex, that is the coordination pair, is an anionic coordination pair. So I cannot write iron. I'll have to write ferrate. So this will be trioxalato ferrate, and then the oxidation state of potassium I have to write in Roman numerals. So let's calculate. So 3 potassium plus iron plus 3 oxalate. So 3 plus x plus 3 because potassium has a +1 charge and oxalate has a -2 charge. So that gives you iron's oxidation state as +3. So just write 3 here. That's it. This is the entire name, potassium space trioxalato ferrate. So now we have a name of a complex in which both the cationic part as well as the anionic part is a complex. So we saw how to find out the oxidation state, and this exact complex, that is the exact entire complex, we found out the oxidation state for. What we did was we assumed it was 2 positive and 2 negative. First we assumed that it is 1 positive and 1 negative, our answer was not correct according to that. So we assumed 2 positive and 2 negative. And assuming 2 positive and 2 negative gave us the oxidation state of platinum of the cationic part as Pt plus 4 into 0 is equal to plus 2. So the oxidation state is plus 2, and that of the anionic part is Pt plus 4 into minus 1 is equal to minus 2. So x minus 4 is equal to minus 2. So x is equal to plus 2. So both of these are in plus 2 oxidation states. Now you will name the cation first, right? So in the naming of cation, this part is the cationic complex. You will name the ligand first. So that's tetraamine platinum, and then the oxidation number in Roman numerals. Then give a space and name the anion. Now anion is also a complex. So you will name the complex. You will write tetrachloro or tetrachlorido. But this is an anion. So the metal name will end in 8. So it will be tetrachloroplatinate